Okay, we're integrating log functions. We're actually not integrating log functions. What we're doing is integrating fractions, and the result will be a log. The reason is, if you differentiate, what we were doing yesterday's lesson, if you differentiate y equals ln x, what do you get? Y dashed is 1 on x. Therefore, if you do the opposite of differentiation is integration. So therefore, if you integrate 1 on x with respect to x, you get ln x plus c. That's our first rule. So if you differentiate log of x, you get 1 on x. So therefore, if you integrate 1 on x, you get ln x. Our second thing was log to the base e. ln is log to the base e. Can I write it as ln? All right. Now, second rule. If you differentiate ln function of x, so log to the base e of function of x, so if we differentiate ln function of x or log to the base e of function of x, what do you get? 1 over function of x times, we did this yesterday, 1 over function of x times f dashed x, which just happens to be f dashed x on f of x. So, again, if you differentiate y equals ln function of x, you get y dashed is f dashed x on fx. So isn't the reverse integrating? So to integrate f dashed x on fx, you get ln of the denominator, function of x, plus c. In other words, if you're integrating a fraction, start with the denominator, write down what it is, differentiate it, and see if that's what the numerator is. Now, sometimes the numerator will be the derivative of the denominator, but a lot of the times it's out by a factor of 2 or a factor of 3, and you have to do adjustments, okay? But if you're integrating a fraction, your answer is going to be a log, provided you've got x's at the top and the bottom. If you've got x at the top and a number on the bottom, that's just integrating x with a constant. Or if you've got integrating, well, if the x is on the denominator, it's a log. If you're integrating something with x on the denominator, it's a log only if it's 1 on x. What if I want to integrate 1 on x squared? Just over here, so you don't get confused. All right, what we're going to do to see why we do this, let's integrate 1 on x squared. How do you do it? So these are the rules. How do you integrate 1 on x squared? That's the same as integrating what? X to the negative 2. What do you get? Girls, how do you, if you want to integrate 1 on x squared, x to the negative 1 on negative 1, which happens to be negative 1 on x squared. Let's try and integrate 1 on x. Thank you. Thank you. So you get negative 1 on x. Thanks. I hope you're writing this down. So, girls, this is your little cue to know why it doesn't work. What if you try and integrate 1 on x the other way? So I'll do that here. Let's say I try and integrate 1 on x with normal methods. I never told you about the logs. What would you do? Integrate x to the minus 1, right? How would you do it? Negative 1. If I did not teach you that rule and I told you to integrate 1 on x, slow down. X to the negative 1 plus 1 is 0 on 0. Why is this impossible? Undefined. So you say, whoops, I can't integrate 1 on x. I can integrate 1 on x squared. I can't integrate 1 on x because of the denominator 0. That's right, that's the log 1. So this is why we have this rule. Does it make sense? Because you can't integrate it normally. But you could integrate 1 on x squared. You can integrate 1 on x cubed, all right? But you can't integrate 1 on x because the denominator of your answer is 0. Does it make sense? Yes, this is in your exam. So if you want to integrate 1 on x, it's ln x. If you want to integrate any other power of x squared on the denominator, it's normal methods. You normally would. You're going to get undefined, and that's the one with the log law. Okay, so the other type is to integrate f dashed x on fx, and that's the type you're more than likely going to get. So exercise 4.8. So question 2b, integrate dx over x plus 3. That is the same as integrating 1 over x plus 3 dx. So we say, right, I'm integrating the fraction. So first let me just check over here, what's function of x? And what's f dashed x? 1. Is this of the format f dashed x over fx? Yes. So, therefore, f dashed x on fx is 1 over x plus 3. Yes. So this is my thing on the side. This is correct. Everything about it's correct. Therefore, the answer is ln, what? X plus 3 plus c. Okay? Please do this working out on the side. All right? That's the first one. The next one's going to be question 2. 2e. Integrate x plus 3 over x squared plus 6x plus 2. Again, integrate it with respect to x. Again, we're integrating a fraction. Start with the denominator. What is it? X squared plus 6x plus 2. What is f dashed x? 2x plus 6. What I'm going to do with that, I'm going to make it, factorize it, 2 bracket x plus 3. Got it? Now, the only thing that you know how to integrate is f dashed x on fx. So I have to write it as f dashed x on fx. I have to. There is no other option. So I write it as f dashed x over fx, but that is not my question. Girls, you are not allowed to write anything else but f dashed x on fx. But that's not my question. What have I done wrong? I've just gone and thrown a 2 on the numerator. How do I fix that? Put a half out the front. You have to put f dashed x on fx here. You have to. Because you are only allowed to integrate f dashed x on fx. That's the only thing you know how to integrate. So you write that, but then you say, but that's different to the question. So balance it out to make it equal to the question. So therefore it's a half. What's the integral of that? ln x squared plus 6x plus 2 plus c. Because it's not hard. It's a matter of recognizing the question. If you recognize the question, integrate a fraction, start with function of x is, f dashed x is, and do your balancing. All right, question, we're going to do one from question 3. Integrating a fraction. What's my thing? Function of x is? X to the cubed plus 2, that's function of x. F dashed x is 3x squared only. Now, so yes, I have to write this as that. So I have to go, well, I know how to integrate this, f dashed x on fx. I know how to integrate that. That is the only thing you're allowed to put there. But is that the same as your question? No. So what do you do to make it the same? Put the third out the front. Do not think of doing anything else but putting f dashed x on fx there. All right, so therefore you have to do the integral of f dashed x on fx. You have to do it. And balance it out to get your question. So it's a third. Now we're doing a substitution this time. So a third what? ln plus 2. Substituting between the values of 7 and 1. A third. ln, what do you get? 7 cubed. What a pain. 243 plus 345 minus ln 3. What can you do when it's... All right, now we're using log laws. A third ln... Oh, no, it's 1 plus 2. What when it's log of this minus log of that, it's ln on 3. That's looking better. A third. And 3 does go into it. 115? Yeah. ln 115. And, well, I don't think 115 is 5 cubed or anything. It would have been nice if it was. It would be nice if it was 125, wouldn't it? We could have had 5 cubed and bring the 3 to the front. Beautiful. But it's not. So I can't think of writing it any other way. Yeah, so work it out now. A third ln 115. Because that's log to the base log to the base a of x minus log to the base a of y. Log laws, girls, log laws. If that was a plus, you'd go times. What's that? A third ln 115. Is it the same as the answer? 1.6. So find the area bounded by the curve y equals x over x squared plus 1, the x-axis, and the lines x equals 2 and x equals 4. How would you do the area? It's the integral. Area under the curve, integral. Now that's area between two curves. This is bounded by this curve and the x-axis. 4 and 2, x over x squared plus 1 dx. I think you know what to do. Can you do your little setting out on the side business? I'm going to pause the video. You're going to have a go on your own. Because you've just done this same type of question. I want fx, I want f dashed x. I want you to write it like that, and then I want you to do the balance. I'm going to pause. So, function of x, x squared plus 1, f dashed x is 2x. You must write f dashed x on fx, the integral of that. Compare it to your question and balance with the half. So it's a half ln of the function of x between the values of 4 and 2. So it's ln 17 minus ln 5. Look, so it's ln 17 on 5. You can work it out on your calculator. 17 on 5 is no special value, all right? You can do it like that or go half bracket ln 17 minus ln 5. But you should always do this in case there's some simplification that you can do. And there isn't one. Because that's 3 and 2/5. Nothing special about that. 0.6 to 2 decimal places, 0.6 to 2 dp. Are we good? Can I move this? The next one's question 9. I'll put it up now from your text. Find the volume. Please write out the formula. Find the volume of the solid formed. Next question, question 9 from your textbook. Find the volume of the solid formed when that curve is rotated about the x-axis. I expect to see a y. I expect to see the formula, the y squared, substituting it in to start with. Write out the formula for volume to start with. Volume is pi b on a. What's the formula? Y squared dx. So pi, what's your b and a? 5 and 1. Girls, it doesn't matter with volume to draw it, because whether there were bits below or bits above, when you rotate, it ends up above and below the x-axis anyway. So, what's y squared? No, it's... If you need to work it out on the side, it would be 2 squared over root 2x minus 1 squared, which happens to be 4 over just a normal 2x minus 1. Alright, this is an interesting one. Right, let's work over the side with our function of x and our f dashed x. What's your function of x? What's your f dashed x? 2. So that's what I want to see behind the integral. So I've got my pi, my 5 and 1. I want to put 2 over 2x minus 1. Do I put a 2 down the bottom or up the top? Yeah, it's pi times 2. I still need a 4 on the numerator. I don't go over 2 because I'll get 1. I need a 2 times 2 is 4. So of this 4, I keep 2 here and I put 2 out the front because 2 times 2 is 4. Are we good with that? So don't think it's always got to be 1 over outside the front of the integral. It doesn't. It's what do I need to do this, to do to this, to get to that. So therefore it's 2 pi, what do we get? ln substitute in 5 and 1, 2 pi ln 9 minus ln, what's ln 1? It's 0. And if you don't ever guess, you do it on your calculator if you're not sure. If you're not sure about ln E and ln 1, you do it on your calculator. You don't take a guess when you've got the tool you need with you. One wrong guess, 1 mark less. All right? So therefore it's 2 pi ln 9. Ln 9, actually, that's not simplified. 2 pi ln, what's 9? 3 squared. See, ln 9 is not the most simplified answer. No, don't. Oh, well, they shouldn't. Times, how do you simplify ln 3 squared? 2 ln 3. So the most, yes, that can be an answer, but that, if they ask for the most simplified answer, that's not it. It's 4 pi ln 3. Because ln 9 is ln 3 squared. You know, when you've got that, that's log to the base e of 3 squared is 2 ln 3. It's 4 pi ln 3 as most simplified version. That and that are the same. You do them both on the calculator, you get the same answer. But ln 9 is ln 3 squared. Why did I do what? Why did I take out the 2 here? Because I need, no. Well, what's 2 times 2? Isn't that what I'm supposed to have? If I go 2 and a half down the bottom, 2 times a half, what's that? 1. Guys, I need 2 over 2x minus 1. How does, this is what you need to do. 4 over 2x, well, that doesn't equal that. I need a times 2 on the top, on the numerator. I've got 2 on 2x minus 1. I don't go putting a half down here. I'll get 1. Do you see it? So just be careful. Okay, girls, and that's not the most simplified answer. The next question is 11. I'll just pull it up. Here's 11. Find the exact volume you can copy it out now. There's 11. There, can you see it? Be very careful. Be very, very careful. You're rotating about the y-axis. Question 11. Question 11. Find the exact volume of the solid formed when the curve y equals ln x is rotated about the y-axis, not the x-axis. Now I'm going to draw this. 11. I'm going to put it here. Find the exact volume of the solid formed when y equals ln x is rotated about the y-axis from y equals 1 to y equals 3. I'm going to draw it. Do you know what y equals ln x looks like? If you don't, substitute values. What's ln 1?
0. Why are you drawing?
Because I want to show you something. You have to draw it. What's ln 2, whatever, ln 3? What's ln e? What's ln e?
1.
Yeah, it's up. So e is 2.7, somewhere here. Girls, what do you think happens to the curve down here? Do you remember? Does it touch? Does ln 0 exist? It's undefined. Curve looks like this. You are rotating this solid from y equals 1 to y equals 3. In other words, from y equals 1, not from x is 1 to 3. Sorry, I should really, it's not the best diagram. From y is 1 to y is 3, I'll make it a bit higher. Far out. You'll have to go like that. Ignore all this. I need a thing. I do. Okay, so, girls, I'm just, not the best diagram, but we don't need all this. So, girls, if you rotate with regard to the x-axis, what's the formula? Y squared dx. If you rotate with respect to the y-axis, what's the formula? What's the formula? Rotating a b on a x squared dy. I can't see any x squareds here. I've got y equals log to the... Thank you. Make x the subject and you are rotating the same curve, but you're rotating it this way. Now, that equation is y equals log to the base e of x, but I can write it with x as the subject as well. You can write log equations two ways, like that with y as the subject, and you can write it with x as the subject. So I need to make x the subject. Y equals log to the base e of x. Girls, what would give me, what would cancel this log e? Another e. So take e of both sides. So therefore that's gone. X equals e to the y. Are you okay with that? So girls, x is e to the y, so therefore what's x squared? E to the y squared. What happens to that y and 2? Good. So that's what you're doing. E to the 2y dy between which values? Good. Between 3 and 1. Here, I'll give you back your thing. So there we go, that. How do you integrate e to the 2y? Is it 1 on 2? You've got your formula sheet anyway. So it's 1 on 2 e to the 2y. It's the integral, you've got a formula sheet, integral of e to the function of x. No, e to the ax plus b, sorry. It's the formula of the integral of e. Here. One sec. It's 1 on, here, Matt's reference sheet. 2-unit reference sheet, it's coming up. Eventually. It's okay. Here we go. Right, where is it? There it is. Can you see it? This one. Integral of e to the ax plus b is 1 over a. Can you see it? It's that. 1 over a e to the ax plus b plus c. Put that down. So that's where we got that from. So girls, you know this half? I think we should pull it out to the front. So it's pi on 2. Are you okay with that? E to the power of, what do you get? 6 minus e to the power of 2. Because you're substituting in 3 and you're substituting in 1, I don't think you can do anything with e to the 6 and e to the 2. So we want the exact volume, and that's what it is. Pi e to the 6 minus e to the 2 over 2. Oh, e squared is a common factor. So e squared pi e to the 4 minus 1 over 2. Well, like x to the power of 6 is x squared times x to the 4. E to the power of 6 is e to the power of 2 times e to the power of 4. You can make it e squared pi or pi e squared, whatever you like. All good? Units cubed. Okay. Now, we've got to do some others, because you'll only be asking me these tomorrow anyway. Question 11. Question 12 now. Show that. Do I have to, I know what I'll do. This is what Nah, got it. Why can't... Whoa! No, make it... Why? What? No. I want to just go like this. Stick that at the top. Why can't I scroll? I hate... Okay, question 12. There's the question. Are you ready? Shh. Girls, question 12. Show that 3x plus 3 over x squared minus 9 equals that result. 1 over x plus 3 plus 2 over x minus 3. Hence, find that integral. Now, girls, what do you think about the denominator, what you could do there before you do anything? All right, so that's really 3x plus 3 over x minus... One sec. Oh, yeah, I was going from the left to the right. I think so. All right, we'll go right to left. Yeah, too hard. Okay, we go right to left. So right-hand side is 1 over x plus 3 plus 2 over x minus 3. If it wasn't an x squared, it would have been okay, but it is a bit hard. So isn't that just x minus 3 plus 2 bracket x plus 3? If you're supposed to show, please show all steps, at least like that. So you're all good, the cross, the butterfly thing, which is x minus 3 plus 2x plus 6 over x squared minus 9, which is, what's that, 3x plus 3 over x squared minus 9. That's part A, all good. All right, now, let me just move this all up. And I lost it. It's all right. Hence, it's okay, we did it. Hence, find the integral of 3x plus 3 over x squared minus 9. I don't know why. Oh, yeah, we couldn't have done it the other way. We couldn't do this the other way. Do you know why? What's function of x? X squared minus 9. What's f dashed x? 2x. There's no way you're going to change a 2x into a 3x plus 3. You could have changed it into a 3x, but not a 3x plus 3. Do you see that? That's why this can't be done that way. So I would have needed just a 3x on top or something, and I would have been able to work with it. Now, so that equals, same as the integral of 1 on x plus 3 plus 2 on x minus 3, plus that integral. Do you get what I'm doing? So the integral of that is the same as the integral of all of this, which is the same as the integral of that plus the integral of that. Not yet. So with the bottom one, I need to do that somewhere. What's function of x for the first one? X plus 3. What's f dashed x? 1. Does that one work? Ln x plus 3. But this other one, it doesn't work. So I'm just going to put the other one down here. Function of x is x minus 3. F dashed x is 1. So I have to do that. But I need a 2 on the top. I don't put, so plus 2 times that. Do you get it, girls? So the first one's fine. With the first one, function of x is x plus 3. F dashed x is 1, all good to go. With the first one, right? With the second one, it's not good to go. I need 1 over x minus 3, but I need 2 times 1 gives me 2 on the numerator. So therefore, that one is ln x plus 3. Yep, oh, I'll put it at the end. Plus 2 ln x minus 3 plus c now. Now when you're, I can't add these yet. Got a bit of a problem. I've got to go over the page. Plus c, I got it. Wait, I got a problem. I can't add ln x plus 3 to ln x minus 3 at the moment. Yeah, no, one sec. We're going to use a log law. The reverse of the way you know it. So I've got Wait, yeah, it will be times, but without the 2 at the front. I've got this. Are we okay with this so far? So I've just moved that from here to there. Girls, tell me where this 2 can go. Good. So now if you want to use the law where you're adding, there's no point doing this, but we can do it. ln what? Actually, I probably could have kept it. Now, how else? I think that'll do. That is x squared minus 9 times x minus 3. Well, girls, isn't the rule plus you times? I'm not sure which way is going to be the most. Do you want to have a look? It could be ln x squared minus 9 times x minus 3 as well. Anyone? What does the question say? Can anyone with the book? Question 14. Let's try question 14. Because I can tell that you're going to be asking me tomorrow. Question 14. Find the indefinite integral. In other words, integrate this. We don't have a rule on this, do we? So maybe we need to, so we're trying to, if y equals, or if that's dy dx, we're trying to find, 1 minute, times 3 to the negative 1 or over 3. That's not going to help me. That's 3 to the 2x times 3 to the negative 1, which is 3 to the 2x over. Question 14 for now and come back to it. Question, excuse me ladies, question 15. Find, correct 2 decimal places, the area enclosed by that curve, the x-axis, the lines x equals 1 and 3 by using Simpson's rule with 3 function values. If you weren't sure how it looks, why don't you just do, if you want to sort of do a quick sketch, you know, when x is actually not a quick sketch, you're going to need to know values. X values, y values. When x is 1, what values are you going to use, guys? I need to make that a bit smaller. So copy out the question. And, girls, please, can we have an attempt? What do you think your 3 function values are? Find, correct to 2 decimal places, the area enclosed by that curve, y equals log to the base 2 of x, the x-axis and the lines x is 1 and 3. All right. How are you going to work out the y value at that particular point? Log to the base 2 of 1. How do you do that on your calculator? Because you can't. You can only do log to the base e on your calc. How do you do it? ln? ln1 on ln2. What's ln1? What? It's 0. Log to the base 2 of 2. This isn't as bad as what you think. What does that equal? It's ln2 on ln2, which is 1. And log to the base 2 of 3 is ln3 on ln2. I'm going to write it as an exact ln3 on ln2. So now, when you use your Simpson's rule with 3 function values, you know, I can sketch this. When x is 1, y is 0. When x is 2, y is 1. And when x is 3, what was y again? What's ln3 on ln2? Approximately equal to. So somewhere here. So in other words, you've got to find the area of this. Find the area enclosed by that curve and the x-axis. So, how do we do it? What's Simpson's rule? It uses, and you must put is approximately equal to, isn't it h on 3 and the multiplier pattern is 1, 4, 2, 4, but if there's only 3 function values, it's 1, 4, 1. Girls, Simpson's rule has multiplier pattern 1, 4, 2, 4, etc. But if there's only 3 function values, it's 1, 4, 1. The 3 function values is actually on your formula sheet. And it's h on 3. So what's your h, distance between? It's 1 on 3, 1 times 0. So 1 times 0 plus ln3 on ln2 plus 4 times 1. See, it's 1 times that plus 1 times that. So instead of doing 1 times that plus 1 times that, you do 1 times that plus that. So it's approximately 1/3, 1, in other words, ln3 on ln2 plus 4. Is that the answer, girl? Now, that's an approximation. If this was 5 function values, you would have done 1, 1.5, 2, 2.5, 3, and you would have had 1, 4, 2, 4, 1 for 5. Simpson's rule must have an odd number of function values, but trapezoidal rule doesn't have to have an odd number of function values. But Simpson's rule does. Because with trapezoidal, you do 1, 2, 2, 2, 2, as many 2s as you need. But Simpson's rule, you're not allowed to have 1, 4, 2, 1. It's got to be 1, 4, 1 or 1, 4, 2, 4, 1. It's symmetrical, the multiplier pattern. Or 1, 4, 2, 4, 2, 4, 1. Yeah. Okay, girls. With question 14, it's actually an extension question, and it's good practice for us. So this is extension 1, integration by substitution. So the way you would be given the substitution, they would say let u equal 2x minus 1. Therefore, what do we do normally? Du dx is, do you remember? They'll give you a substitution. So let u equal 2x minus 1. So the next thing we do is du dx is 2. Therefore, du equals 2dx. Do you remember that? Or dx is, instead of that, dx is du on 2. How about that? Why do you think I'm coming up with dx? So I can substitute it in. So now, therefore, the integral of 3 to the 2x minus 1 dx is the integral of, I don't want to see any x's anymore, I need all u's. 3 to the u, which we don't know how to integrate. And what do you replace the dx with? Which is a half 3 to the u, half times the integral of 3 to the u du. Now, we need to change, we've been integrating things like 3 to the x. When we look back at, no we haven't. Integrate a half times the integral of 3 to the u. I'm letting y equal 3 to u, okay? So if y equals 3 to the u, then u equals log to the base 3 of y. Now, change of base, that's ln y over ln 3. That's what u is. So therefore, to the ln y on ln 3, which is a half end of lesson, we'll continue. Okay, girls, I'll get back with the question 14.